Yeah, so good day guys, welcome to Back School Academy YouTube channel. And this is like our first video and I'm so glad that you want to take it. So do well to subscribe, like this video because what I'll be teaching here, the way I will teach here, you will 100% understand and you will even follow with it. So you might ask that, what is our Back School Academy? What do we do? Why are we doing all this? So we are an online tutorial. I don't like the tutorial, people don't use them too much. So we're an online academy that we teach students on admission related exams like JAMB, UTME, School of Nursing exams, and I can guarantee you that if you enroll with us, we surely blast your exams. But who am I to say that? Why will you believe me? So let's go through this class and let's rate your understanding after I teach this topic. So today we're looking at the subject of chemistry. So I did a survey. I was like, which topic or which subject should I take in the three science subjects? Maybe we said chemistry. I was like, okay, which topic under chemistry should I take? And I excluded organic chemistry and stoichiometry for a reason, because I will compulsorily take those ones, and those ones are really bulky and take me a lot of preparation and a lot of things. But I want to make this video real quick. So we're looking at redox reactions. That's the one that I said I would pick from the options that were given to me. And quantitative redox reactions. This is like a very popular topic in chemistry. Quantitative redox reaction and teach you to understand. There are some concepts that you must know, or there are some background knowledge that you must have on some concepts like the meaning of oxidation number, what does reduction means, and even how to name ionic compounds. I would have loved to just dive into the main subject of the day. I also have to bring the reaction, but I want to make sure that everybody's knowledge is grounded, so that when I go deeper or when I go to where I'm going to, the moment I'll be left confused. So now, redox reaction. The reason why it's named redox reaction, because this one here means reduction. I hope I'm writing clearly. This one means what? Oxidation. So redox reaction simply means reaction that undergo what? Reduction and what? Oxidation. And before you can know if an element or a particular compound undergo reduction or oxidation, you must know the concept of what? Oxidation number. You must know the concept of oxidation number. Now let's look at that. Now it means that in chemistry, what is oxidation number? It's very simple. One thing I like about my teaching is that I don't really confuse you, because last you won't really need all these things, all this definition. I'm not sure in JAMB you'll be like, what's the definition of oxidation number? And even they ask itself to be a very simple answer. So oxidation number is like the formal charge that is assigned to an element or an ion. Let me explain it. Now let's take for instance sodium. This is sodium now, sodium ion. Now this is the sodium ion. Now the oxidation number of sodium here is what? Is +1. There's no need for really putting 1 here because it's the same thing. So this number is like a formal charge. This plus means what? A positive charge. If it was negative, like Cl minus, this is chloride ion. So it has what? So the oxidation number here was +1. Why for this one is what? Is -1. So oxidation number is like a formal charge assigned to an element or an ion. You might say that SAP, because now this sodium is like this in its normal state. This is sodium ion, this is sodium. The oxidation number here is what? Is 0. And I will explain to you the rules guiding oxidation number, because there are some rules that you must know before you can know how to assign oxidation number to elements. So I will just give some rules, some brief rules, and it won't take too much time. And the first rule, let me call it rule 1. Rule 1. You can be jotting place. The first rule is that an element in its uncombined state, that means that element has not undergone any reaction, it's just there. For example, sodium. This is just sodium. For example, chlorine, Cl2, or magnesium. Now all these elements, they are in their uncombined state. Do you see sodium reacting with anything, or chlorine reacting with anything, or magnesium, or with hydrogen? Basically, any element you have seen that is in this uncombined state, their oxidation number is what? 0. Do you understand? Their oxidation number is what? Is 0, because they are in the uncombined state. Do you understand? Now, the second rule is very, very simple. The second rule is that, NECO rule 2. I'm not really writing, I don't want to. You can be jotting. Let me come again. The first rule is that an element in its uncombined state, the oxidation number is what? 0. Now, the second rule is that an element that, an ion, the oxidation number of an element or an ion is equal to the charge that is placed on it in layman terms. Let me tell you what I mean. Now, this one is Na plus. This is Cl minus. This is SO4 2 minus. This is CO2 3 minus. Now, looking at these ions, these ions, their their oxidation number is plus. For the sodium is what? +1. For chlorine is what? -1. Or for ions that have more than one atom in them. For this one now, the oxidation number for SO4 is what? -2. For this one is what? -3, and so on and so forth. Now, do you understand? Now, the next rule that I would like to touch is that there are some on the periodic table. We have the group 1, the group 2, the group 3, the group 4, group 5, group 6, group 7, and the group 8, or call them group 7. They have like oxidation numbers that are assigned to them. For example, now, okay, for example, now, let me put out group 3, the group 1 element. Their oxidation number is what? Is 1 plus 1. You get, for group 2 elements is what? +2. For group 3 elements plus what? 3. Now, before I go on, I'm very sorry. I failed to introduce myself. So my name is Obakoyiwa Ivan, and I'm a medical student of Obakoyiwa University. One of the things I love doing is teaching. So I'm the CEO and the owner of Obakoyiwa Scholars Academy. So I think that's good. So we'll think that the group 1 element is what? Their oxidation number is what? +1. For group 2 is what? +2. For group 3 is what? +3. Now, when we go to group 4, of course, group 4 is +4. Even group 5 is +5. But the thing is that most times, for the sake of UTME, for your level, most of the reactions that will be carried out, or the questions that you see, they will really go down the group. No, we still have many elements down the group. But so for group 4 elements, is what? +4. Now, the reason why when I did 1, 2, and 3, I didn't really give comments on it is because for these group 4 elements, there can be variation. For example, now, the oxidation number of carbon is +4, but there are some compounds that you will see carbon there, and carbon will have the oxidation number of what? Of 2. So please, it can vary, but most times, for general knowledge, it's +4. But elements like in group 4, group 5, and yeah, from group 4, group 5, it mainly depends on the compounds those elements are present in. For example, now in carbon, this is carbon monoxide, this is carbon dioxide, this is carbon, this is carbon. The oxidation number of carbon here and carbon here is different. But carbon is a group 4 element. Why is not 4 here and it's 4 here? There are reasons to it which we will discover later on. So for group 5 elements, is what? +5, and sometimes can be -3. Check it. +5 and -3. And I will say it again, it depends on the compound they are in. For example, a very popular group 5 element, and which is in the first one, is nitrogen. And you can have compounds like NO2, you can have compounds like NO, you can have compounds like N2O. And the oxidation number of nitrogen here, I think is 4. For nitrogen here is 2. For nitrogen here, I think it's 1 minus 1. So you get you see that the oxidation number is varying based on the compound they are present in. But generally, it's plus 5 or minus 3. Do you understand? But we'll go there deeper. So for group 6 elements is what? Minus 2. And the reason why I said for group 7 minus 2 because we know that the most popular group 6 element is what? Oxygen. And the oxidation number of oxygen is what? Minus 2. And for group 7 elements, group 7 elements normally is minus 1. But they can vary too. Now everything just vary. They can vary too. They can vary from minus 1 to as far as minus 1 to as far as you can have different numbers like minus 1, you can have minus 5, you can have minus 6, minus 7. That's when they form inter-halogen compounds. Like when you say ICl3, something like this. This is an inter-halogen compound because please, you know these group 1 elements are called alkaline earth metals. Group 2 elements are called alkaline metals. Group 3 elements are called metalloids. Group 4 elements, you can call them the carbon family. Group 5 elements, you can call them the nitrogen family. Group 6, the oxygen family. I don't want to start saying the halogens. I don't want too much confusion. Why the group 7 elements? They are popularly known as what? As the halogen. And when we say that we have inter-halogen elements, or sorry, inter-halogen compounds, we are saying when a group 7 element reacts with another group 7 element. Do you understand? That is when their oxidation number can vary, ranges. Do you understand? So let us begin. Why for group 8 elements, their oxidation number is what? Is 0. Do you understand? Their oxidation number is what? Is 0. So all these things are not really bulky things. That's what I can know. Group 1, 1, group 2, 2, group 3, 3, group 4, 4, group 5 can be plus 5 or 3. And group 6 element is what? Minus 2. Group 7 is what? Minus 1. And group 8 is just 0. You don't really, you don't have any oxidation number. And one thing you can use to like remember or to like remember is oxygen. Just know the first elements of these groups. Now for group 6 now is oxygen. Even before you even watch this video, you know that commonly, most times, we are calculating oxygen number. The oxygen number of oxygen is what? Minus 2. And for chlorine, for fluorine, which is the first group 7 element, is what? Minus 1. Now the thing is that even after all this, there are still some things that we need to know about oxidation numbers, because I told you that oxidation number varies based on the compound that element is in. Do you understand? Now, we all know, but by default, the oxidation number of hydrogen is what? Plus 1. Do we get? But that can vary depending on the type of compound that hydrogen is in. Yeah, so guys, we've looked at all this, and for the sake of some people, or for the sake of all of us, I said let me write the rule so that you can copy it, and I think this one will stick more better. So let us go over it again. I said for elements in an uncombined state, that is, they don't react with anything. Yeah, for elements in an uncombined state, let me say this. For an element in an uncombined state, e.g., sodium, potassium, and calcium, or one whose atom combine with themselves to form molecules. All those diatomic molecules, that is a molecule that has more than one atom. For example, hydrogen molecule has 2 hydrogen atoms, while fluorine has 2 fluorine, same thing. So when you see elements like this and like this, their oxidation number is what? 7. Here, oxidation number is what? 0. Let me spell it 0. 5 is 0. Yeah. And what else? For a simple ion, the oxidation number is the actual charge carried. For a simple ion, the oxidation number is what? Is the actual charge carried. And this is a very good example. For sodium ion, Na plus 1. Calcium ion, Ca2 plus. The oxidation number is what? Plus 2. For oxygen ion, O2 minus. The oxidation number is what? Plus 2. And I talked about this group 3 that the group 1 element are plus 1, group 2 element is plus 2, group 3 element is plus 3. And I was now talking about an element called hydrogen. And hydrogen, you can put hydrogen in what? In the group 1 element. Yeah, you can place hydrogen on that group 1, or even on that group 7, the matter. Yeah, so hydrogen, the oxidation number of hydrogen is plus 1. Let me write it down. The oxidation number of hydrogen is what? Plus 1. Now, one thing about chemistry is that the reason why chemistry is chemistry is because there are a lot of exceptions, there are a lot of anomalies, there are a lot of abnormalities. Now, the original number of hydrogen is plus 1, except there will be an exception, except in ionic hydrides. And what ionic hydrides? Very simple. When a group 1 metal combines with hydrogen, they call what? Ionic hydrides. Or let me say, when a metal combines with hydrogen, it will be what? An ionic hydride. And a very popular example is what? Sodium hydride. NaH. This sodium hydride. The inputs Ag, sodium hydride. So in this compound, the oxidation number of hydrogen is not more plus 1. It is now what? Minus 1. So say that the number of hydrogen is plus 1 except in ionic hydrides. Example, sodium hydride, where it is minus 1. So the number of hydrogen is what? Plus 1 except in ionic hydrides. Example, sodium hydride. And if you want more example, you can say magnesium hydride. Yeah, that's a metal with hydrogen, So in this compound, the only number of what? Hydrogen is what? Minus 1. But in every other compound, we see hydrogen present in. So far, it is not an ionic hydride. The original number is what? Is plus 1. Now, the number of hydrogen here in this ionic hydride is what? Minus 1. That is why you can put hydrogen in group 1 and you can put the same hydrogen in what? Group 7. Because group 7 elements, their oxidation number is what? Minus 1. So there's no really a particular place for hydrogen in what? In the periodic table. It can behave as a group 1 element and even as a group 7 element. It behaves as a group 1 element when its oxidation number is what? Plus 1. It behaves as a group 7 element when the oxidation number is what? Minus 1. Do you understand? Now, the second one is for oxygen, because we will solve questions that should be asked for the oxygen number of a particular element. And most times, the atoms that will be there will be hydrogen, oxygen, and some other atoms that their oxygen number is what? It's very, very common. And you have to know some certain rules. So for oxygen, for oxygen, the oxidation number is what? Minus 2. That is telling that, no, I think here, can you see that? It's me here. Normally, the oxidation number of oxygen is minus 2. Except you see oxygen in some particular compounds which we name here that their oxidation number what? Varies. So for oxygen, the oxygen number is what? -2. Except in, let me put it like accelerate, peroxides. Peroxides are compounds that they have double oxygen, maybe they have double oxygen. Except in what? Peroxides and what? Super oxides. Yeah. Except in peroxides and super oxides. An example of peroxide is what? Hydrogen peroxide, e.g. hydrogen peroxide. Even sodium peroxide is there. And we have super oxide, example, potassium oxide. Do you understand that? Now, in elements like this, peroxides, in elements like this, the oxygen number of oxygen is what? In peroxide is what? -1. For example, in peroxide is what? -1. For superoxide is what? -half. For oxygen, the oxygen number is -2, except in peroxide. Example, hydrogen peroxide, in which the oxygen number is what? -1. While for superoxide, for example, potassium oxide, in which the oxygen number is what? Or the oxygen number is what? -half. Sure you get it. So, do you understand? So, the number of oxygen here is no more -2, and we can actually calculate it. I don't do that now, but let's do it for peroxide to show it to you that this is really true. So, let's assume that we don't know the oxygen number of what? Oxygen in this compound. Let's assume that. And we know that the oxygen number of hydrogen is what? Is +1, except in ionic hydrides. But this is not an ionic hydride, this is like a normal compound. So that means we are expecting the oxygen number of what? The peroxide of hydrogen here to be what? +1. Now, another rule that I must tell you in oxygen number is that when you look at compounds or ionic compounds, the oxygen number of a compound that is neutral. A neutral compound is a compound that is not carrying any charge. So the oxygen number of that compound is what? 0. You get it? Or let me do it this way. Let's turn the camera here. So yeah. So I will come back here to prove to you that the oxygen number of oxygen here is what? -1. I can do it yourself before I even come back here. So there's 3 bases. Let me do that 4. The algebraic sum of oxidation numbers in a neutral compound is what? 0. Now, this is telling you that you can actually add oxidation numbers together in a compound. You can add them. So this is telling you that when you are adding the oxygen number in a neutral compound, the oxygen number, the algebraic sum of those oxygen number that you add will be equal to what? 0. The best way I can explain this is by just giving you an example. For example, now let's take an example. Let's say sodium hydroxide. Now, this is a neutral compound. How do I know? Do you see any +1 or -1 there? No. So this is like a neutral compound. Change. So it means that if we add the oxygen number of sodium, the oxygen number of oxygen, and the oxygen number of hydrogen, if you add everything together, it gives us what? 0. So what's the oxygen number of sodium? +1. I mean, for oxygen is what? -2. Why for hydrogen is what? +1. Please, because we saw sodium in, don't make this is an ionic hydride, because this is an hydroxide. So let's add it together. +1 -2 +1 give you what? 0. Now, that brings us back to this. Telling you that we can look for the oxygen number of what? Of oxygen here, because this is also a neutral compound. Because we're not seeing any charge here. This is 1. It's telling that the oxygen number of oxygen in this element is what? Is 1. So I mean it's minus 1 rather. So this is minus 1. It's not just it's 1, it's minus 1. This is minus half. So let's calculate the oxygen number of oxygen in hydrogen peroxide. Let's do it here. So put H2O2. One for the oxygen number of oxygen. So we can write let oxygen be what? X for easy calculation. So it's not really compulsory, but you can do it your own way. So and everything will be equal to what? 0. So put I'm not going to minus we have 2. So put 2 times the oxidation number of hydrogen, which is what? Which is 1. Plus how many atoms of oxygen do we have here? We have 2. And we don't, it's unknown. The oxygen, okay, let me do this. Let the oxidation number of oxygen be X. You understand now? So we have 2 atoms of oxygen here, that is 2 times the oxidation number, we don't know it, and we call this what? X. So since a neutral compound, if we add everything together, it's going to give us what? 0. You understand? Now, what remains now is not mathematics. That will be 2 plus 2x equal to 0. And that will be 2x equal to what? This one will come out here. Minus 2. Then you divide this side by 2. Then x equal to what? Minus 1. Now, that is showing that the oxygen number of oxygen in this compound is minus 1. Do you understand? So it's very, very simple. And if we do the same thing for this potassium dioxide, potassium dioxide, you will still get what? Minus half. So that's also giving you a basic rule. Yeah, a basic rule. And also, the algebraic sum of oxidation numbers in ionic compounds is equal to the charge carried by the ionic compound. Do you understand? So it's very, very simple. So when we look at compounds that are ionic, that they are carrying charges on them. For example, let me clean this board. So, for example, when we have ionic compounds like, let's say, SO2. If you add the oxygen number of sulfur and oxygen here, when you add it together, it will give you what? Minus 2. The same thing goes for CO2 3 minus. When you add the oxygen number of carbon and oxygen here, everything will give you what? Minus 3. So, with this being stated, it can be possible or easy for us to look for the oxygen number of a particular element. Right now, I can't really tell you the oxygen number of sulfur, even if I know it and I think you know it. But we can just say that we should look for it based on the knowledge we have here, because we know that adding all the oxygen number of these atoms there will give us what? Minus 2. And we know the number for oxygen because oxygen is guided by these rules. And this is not a peroxide, this is not a superoxide, this is just a normal compound. So that means the oxygen number of oxygen here will be what? Minus 2. And let us do the calculations. Let me clean this one. So we are looking for the oxygen number of what? Of sulfur. So put let the oxidation number of sulfur what? X. We can put X, right? So we have going to be X plus, we have 4 atoms of oxygen here, plus 4 into brackets. And what is the oxygen number of oxygen here? What? Minus 2, since if you check the rules and it's normal. Minus 2. Everything equal to what? Minus 2 on top. Because that's what it can. So when we do our mathematics, x plus 4 times minus 2 is minus 8. So that will be x minus 8 equal to what? Minus 2. So x equal to what? Minus 2 plus 8. Then x equal to what? Minus 2 plus 8. So x is equal to what? 6. Yeah, 6. So that is telling me that the oxygen number of sulfur in this element is what? 6. Do you get? And we can now dive into calculation of oxidation numbers. We'll not really do much of that because they are actually easy. But let's look at some examples to keep everybody on the same page.